Hello everyone. In today's video, I'm going to talk about inference. I'm going to perform inference on the laptop first, then on the Raspberry Pi 5, and we're going to see how things look like. Here's the main script, the speech command classification, the PyTorch version, and these are just the libraries that we're going to import. So pay attention to the comments that I've put here about touch audio and sound device. On Windows, it's straightforward, but on the Raspberry Pi, you probably have to do some extra stuff. Here is my parser to put the arguments. Here is the label map that we're going to load. So these are my different classes. And here is the architecture that we've already seen in the previous video. Here we are loading the model for evaluation for inference. And here I am performing quantization. So if you don't need quantization, you can just comment that. This is the audio section of the inference code, and you see that we have the same characteristics as during training, sample rate of 16 kilohertz, one channel. Here is where we calculate confidence and entropy, which are important metrics to make our classification perform correctly. Here is the Mel spectrogram. I'm using the same characteristics as during training because, in AI, training and inference are entangled. So the way you're going to perform all the pre-processing you do during training has to be the same during inference. Otherwise, the model is not going to behave correctly. Here is the sound device callback function, and we have an energy threshold here which allows us to filter out silence, because without that your model will try to classify even silence, and the levels that are recommended between 0.01 and 0.05. It really depends on your microphone. On the Raspberry Pi, for example, I'm going up to 0.05 because I'm using a webcam camera. So the webcam camera is both, the camera and also the microphone. The quality is not as good as on Windows. So, it really depends on your hardware. This is where we perform inference. So you can choose between the normal model or the quantized model if you want. This is where the magic happens. Depending on the class, I can perform this or that action. It can be simply reading an audio file. It can be launching another AI model, or can even be controlling servo motors or anything. And this is where you're going to create a sound device stream to get the audio from the microphone. On Windows, you don't necessarily have to use to indicate the device you're using, but on the Raspberry Pi, if you don't put that, it's not going to work. So to make the code more portable, I've made it mandatory in both cases. On, on, off, learn, learn, stop, cut, cut, visual, visual. Stop. Dog. Dog. House. Learn. Off. Stop. Visual. Stop. Instead of YOLO detect, you can choose to use YOLO wave to vec. And what this code does is if you pronounce a word that matches what YOLO is saying, in this specific case, it's gonna play an audio file that's gonna say yes to confirm that what you said is what YOLO is saying. Of course, you can use it in a different way. And the interesting thing with this, it allows you to use words that are not in your original speech command model. And I think it's a very, very interesting extension. And of course, with this code, you can choose to only use wave to vec without YOLO. On the Raspberry Pi, everything works well except for Alphatron. For some reason, this class is very difficult to get identified correctly. The quantized model works a little bit better with Alphatron, but it's still not that good. So I'm going to use the quantized version here. And you can see here for the threshold, I'm at 0.05 because it's more sensitive on the Raspberry Pi. So you see here, I'm not using best model, but the quantized one. Let's check our device. This is my I2S sensor for the speaker, and this is my microphone, the USB camera, which is 2 here. I'm going to use YOLO Piper here. On, off, cut, learn, learn, Alphatron, Alphatron. You can see it's just struggling with Alphatron right now. Alphatron. I can scream all day, but oh, okay, it actually worked. Alphatron. Alphatron. Yes. Alphatron. Well, you know, sometimes it works. Yes, Father. But there's a little bit more starting YOLO instability here. I didn't even say visual, but starting YOLO. You see, stop. Visual. Starting YOLO. Share, bubble. Share, bubble. Share, bubble. So for some reason, everything bubble that's outputted by Piper is identified as cat. Bubble. It's a little weird, but bubble. Stop. You see, the model is a little bit less efficient on the Raspberry Pi, but it can still somewhat catch a few things. And I think that's because on the Raspberry Pi it's just CPU, while on my PC I'm using GPU. Stop. So I mean, let's just stop here for now. And the model that works is more stable here is the Onyx model. So the converted Onyx model. So if I do this, now the Onyx model is very simple, so it's not as heavy as the PyTorch one where I can call all the AI. It's just speech command, but it's let's just see how it works here. Alphatron, Alphatron, off, cut, learn, learn, visual, off, on, 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 Alphatron, Alphatron. You see, this one is a little better than the other one, the PyTorch model, but still, sometimes it catches random classes, but it is what it is. The model can still be improved, maybe by training it, with more data, slightly changing the convolutional neural network, doing this, doing that, there's still room for improvement for sure, but I think it's a good start. Finally, I wanted to talk about SpaceEye. So SpaceEye is a lightweight NLP that allows you to process text. So it will work very well with something like Wave2Vec. So if you have a full sentence and you can say turn on LED, something like that, then with SpaceEye you can break down what's the noun, what's the subject, what's this, what's that, and it allows you to further process something that will come from an ASR like Wave2Vec. You can also, at this point, use an API like the Google API to, for example, I don't know, you can ask for the weather forecast, like what's the weather like, or what will the weather be like tomorrow. And then with the Google API, it's gonna use the keyword weather and start searching it on the internet, and you can read the output with Piper, for example. And you also have the option of training your LLM or using OpenAI API to use ChatGPT combined with an ASR. But here you are really free to do whatever you want and play around with these different things. This is it for the AI arc of the channel. I hope you've learned a few things throughout this series of videos, and I hope that you're gonna push forward. Thank you for watching.